Hi everybody, hi B-Sides. Isn't it great to be back? Yeah, awesome. Thank you to everybody who puts on the B-Sides talks. Appreciate everybody who's involved and volunteers and sponsors. Like Andy said, just everybody, thank you. You're here for malicious intent for the open source supply chain. So thank you for joining me. So a little bit about this presentation. Its goals are to help you understand the open source software supply chain threats and help your organization make better risk-based decisions and recommendations for improving your supply chains and your DevSecOps processes. So what we're going to do is go through a little bit about me, talk about why this presentation, as this is a journey, much like Sid had a journey along with his presentation. We'll go through some key concepts, talk about open source. We're going to talk through primarily two different types of supply chain attacks, third party and first party. And I'm going to talk through some concepts, some example attacks, and some guidance and recommendations and some really cool tooling I've found along the way through both of those. And we'll wrap up with some conclusions. So just a little bit about me. You know, I'm just an excited cybersecurity professional trying to help the rest of the industry learn what I learned. So several years ago, I discovered there's a whole new world of cybersecurity within the challenges, security challenges within the software development community. So I really wanted to learn more about this. And so as I was preparing for this talk, you know, I found several really interesting things that got me excited along the way. Like metric frameworks, maturity frameworks, compliance frameworks, tooling, and I do include a lot of these things into my presentation. So I tried to make this presentation as interesting as both technical and leadership. So I may go super fast through the material, but just a reminder, this will be posted on YouTube, and the slides, I'll give you a link to the slides at the end of the deck. So very quickly about me, I am these things in this order. I'm a Christian, husband, father, and a manager of a cybersecurity team for the National Technology Energy Lab, or National Energy Technology Lab as a support contractor under Maximus Attain. I got lots of experience, very much like Sid, you know, just many different industries in cybersecurity. I got a bunch of certifications as well. But do note that I am not a programmer or developer. I do know how to program. I use open source software like much of you do, but I am not in software management and development for a living. But this presentation is my perspective as a cybersecurity professional to you who are cybersecurity professionals. All right, why? So I help organizations to improve and mature cybersecurity. It's my job. So I've heard of many people having experience with the SolarWinds investigations and incidents. And it certainly was an eye-opener for many in the industry. So I also work for an organization that relies heavily on open source software. So, and I expect every one of you in the room has all downloaded and utilized open source software and binaries. So I had a question. I wanted answers to a lot of questions. So what I did is I did a ton of research. I read a lot of articles. I read blog posts, I listened to podcasts, and most recently I attended the 2021's North American Supply Chain Security Con just a few days ago. Finally, I want to alert others to encourage you to speak publicly. So I want to be an example to others that it's okay and very possible to pick a topic you're not familiar with, learn in a short amount of time, and present what you learned. What better way is there to learn than to force yourself to teach others? So I did not get the answers to all these questions, but I got pretty close. So let's go through some key concepts. You may have heard of Linus's law. It's the assertion that given all eyeballs, all bugs are shallow. And that's you know, a lot of eyes help make good code quality and good projects. I'd also like to think in the cybersecurity world, it's kind of a separation of duties control. This, and this also helps this concept also helps make secure code and good quality code, good security. Obviously, code reuse and code functioning and reuse is an obvious goal. We'll talk, that's just a key concept in open source and in software development in general. And then there's an article about 35 years ago by Ken Thompson called Reflections on Trusting Trust. Basically, it was an article that referenced one of the first software supply chain proof of concepts, where he wrote some C code to attack, I guess, the compiler of C to do malicious things. We're going to get back to the concept of having a build process being attacked. So a single software supply chain. This covers, so what is a software supply chain? It covers from the keystrokes of the developer developing the code, to the source code management solution, like GitHub, to the continuous integration, continuous development processes, and importing the dependencies, where a piece of software would import dependencies, like Sid was mentioning with Ubuntu, and package just all the way to the distribution points of being provided to the end user. Distribution in open source, Sid had mentioned APT, Yum. In the open commercial world, it is like the Apple Plays and the Google stores. So an attack against this supply chain is any unauthorized, Google defines it pretty simple, any authorized modification within that process. And we're going to go through many different attacks through this process. Like I mentioned, there's two general software supply chain attack types, first party and third party. But first, let's talk about open source. It is the scope of open source. It's huge. And this is good to review some of these statistics. 98% of code bases contain open source components, and roughly about 90% of enterprise software is comprised of open source code. So the community is huge, and it's growing. It's almost growing exponentially. So that was something that really kind of surprised me as I was doing some of my research. Interesting fact too, that the Windows operating system is built on a large quantities of open source code. So I wanted to talk about third-party software supply chain attacks. Basically, it's somebody else's software supplying. It is what Sid was referring to as upstream. And we're going to talk, when you talk about third-party other people's code, you're talking primarily about the dependencies. A modern application contains roughly 128 open source dependencies. So this you can see how just a lot of different, all the complexities within the supply chain, specifically around dependencies, there's lots of challenges there. This is what's known as a dependency graph, very, very, very simplified, so you can help understand. If you have a compromised open source project, well, downstream projects, or even your commercial off-the-shelf project, can be affected. Very similar to inclusions between other open source projects that make their way down into your final open source project. This concept can be applied to both malicious code functionality and injection of code and the vulnerabilities, as Sid had mentioned. Wanted to go through an example attack. This is an attack that happened maybe 2 years ago with the EventStream open source solution. Basically, EventStream was a dependency of a Bitcoin wallet called Copay. What happened was the attacker made some really meaningful contributions to the EventStream project, was able to, the owner of the project granted that attacker permissions to take over the package, and malicious code was injected by that attacker. And so the real key point here is, at the upstream open source project could affect many different downstream and target downstream applications and projects. At the time, EventStream was used by roughly about 1,600 packages. This EventStream project averaged roughly around 1.5 million downloads a week at that time. The good news with this attack, that there was really no known impact to the Bitcoin users of the application. So that's from Bitcoin in their statement, or BitPay in their statement. So this graphic demonstrates a big problem for open source software. You know, developers work on popular code, what is popular, and people stop working on old code. You know, what happens is, it typically happens is developers typically starts with a personal account, the project gets big, and then it gets old, and then the projects can expire. This is a big problem. That one random person in Nebraska can often get hit by a bus, or is hired with an organization that pays huge amount of money and forces that developer to stop working on the open source project. This problem may have contributed to why the event stream project owner may have granted permission to that attacker with possibly maybe little vetting. So purposeful zero-day vulnerability injection. So Sid was talking about maybe vulnerabilities that were not necessarily purposeful, but attackers, the 2021 State of the Software Supply Chain report by Sonatype states that the attackers are starting to more and more inject zero-day vulnerabilities into open source projects that feed the global supply chain. So this is a very scary thing. You know, you all remember Heartbleed and Struts. I mean, that was a vulnerability that affected thousands and thousands of organizations, and it was a big cleanup. Now, I have no evidence that either of Heartbleed or Struts or vulnerabilities were maliciously injected. I'm not saying that, but they are great examples how a single vulnerability can affect thousands of downstream applications that depend on it. However, with the statement from the report, in my research, I've really found no good examples of a purposeful zero-day vulnerability injection attack. So if anybody knows of a good one, please just see me afterwards. I'd be interested to hear that example. All right, another attack within the dependencies is the dependency namespace confusion attack. Basically, within this exploits DevOps tools and their default configuration and how they automatically update their dependencies. If a tool is configured to automatically update dependencies, what they're looking for, the name, typically the name of the dependency or the package, and a version number. So if they see a .1 update, they're going to go grab that from an internal repository. What this attack does is it takes some code tools are, the attacker posts a public version of this very similar named and versioned, or a .1 version of the repository that is malicious. But the attacker needs to know some of that inside information to do that. So basically, the one thing you need to do and look out for this type of attack is to configure your DevOps tools to appropriately prioritize where they get their packages from. So make sure they're configured for your internal trusted repositories rather your potentially public repositories. Or have some other controls to check prior to download. All right, so I talked about a lot of problems. What do we do? I want to go through something called, what I call dependency management health with developers and warning for cybersecurity professionals. Go through some tooling and some really cool processes and tools. The good news is a lot of these processes and things that I'm going to be going through are measurable and are helping development teams working toward automation. So first, a warning, dependency management health. So project developers, as Sid was mentioned, they struggle with managing dependencies. It's a royal pain. It's a balance between innovation and getting the project done and maintenance of your code. They struggle with this, and I just want to make sure we're all aware of that struggle. However, risk-based quantification and decision automation capabilities are improving. They're getting a lot better, but they may not be there yet. Just some pro tips for for working with developer tools, development teams. Just be patient. Don't force your tools or processes. Let them come up with their solutions, and seek win-win solutions. Meaning, When you're looking at solutions, don't look at just security as the primary goal. Help them mature their code, and make their processes more efficient at the same time. That's a whole nother talk we can go to, but just quick tips. The Sonatype report I mentioned earlier has some pretty good guidance for developers, and there's some 8 rules when to update your dependencies. Sid talked about updating the most latest and greatest dependencies. This report was suggesting that we do not, or there's concerns with updating the latest and greatest. You may not want to do that. So there's some, one of the key takeaways of this report is to consider how you can make the best decisions for updating your dependencies. So there's a lot of tooling out there. GitHub has dependencies and a dependency graph. In the project, you list all your dependencies. There is some alerting functionality that's possible from like the Bettabot, and OWASP dependency track is also another tool to help be alerted of issues within your dependencies. OWASP dependency track that primarily uses SBOM, which I'll get into a little bit. This is an example of a dependency graph, just showing just how complex it could be. And this is a really interesting solution from the Open Source Security Foundation. That foundation has a lot of different really awesome, interesting projects. I reference a few of them in the slide deck. But there's a project called Scorecard that allows you to input your Git repository, and the output is a weight-based scoring metrics across 16 different tests. It helps to identify whether your dependencies are safe or not. Why is this really interesting? Well, it could help you make automated risk-based decisions. Perhaps your organization or you can define a minimum OpenSSF scoring criteria for your dependencies. Here are the 16 checks. It covers a lot of different areas of the package. So software bill of materials is very important with this problem. What is a software bill of materials? Well, I'm going to just call it SBOM. Well, it really helps with identifying, with automation and identifying the trust of a software package. It includes ingredients of your package such as source code, summaries, application builds, container images, running containers, checksums, hashes. It's the whole complete inventory. It's very, very, very good metadata of a project. A mature project will have an SBOM. The SBOMs are developed at build time because that's where a lot of information is gathered. And it also includes the dependencies listed in the dependency graph I referenced earlier. This data can be very useful for security functions and asset management functions along the lines for patch management, getting good threat intelligence of what's listed in the software, vulnerability management, understanding the dependencies and the chains there, and disclosure. And it's also used for disclosure processes. Because there's information that lets you know, okay, well, if a certain dependency, you could let other downstream, repository and incident response teams can let downstream package owners let them know what's some problems within their downstream packages. There's lots of great tools that out there that make this easy. There's Gitbomb and Sift, and SPDX is a standard. Another standard that's out there is OWASP Cyclone DX. That's another tool. It's been also popular as well. You're going to see, recently the U.S. government has increased the awareness of the software supply chain attacks, and SBOM is a very frequently referenced solution to a lot of these problems. Okay, first-party software supply chain attacks. Basically, this is your project's or your organization and its software supply chain. This relates to many attacks that the DevSecOps controls and tooling prevent. SolarWinds is a prime example of a first-party supply chain attack. The malicious code was injected into the Orion software at SolarWinds through a highly targeted part of the CI/CD build process. That's how originally the malicious code got into the SolarWinds project. That's an example of first-party supply chain attack. So here are some points. I got these some great graphics from the Salsa team, and I give credit to them for a lot of the graphics in here. They explain it much better than I can explain it. But all the way to the left, if we running through the software supply chain, submitting bad code. Yep, you can have a bad actor, like the event stream actor, just writing bad code. Software, you could compromise the GitHub page example, or your GitHub, or your software control management solution. And as you could also attack between the software management solution to your continuous integration and continued development build processes. You could also compromise that build platform. And as I mentioned before, you can inherit or include bad dependencies. As the software is built, it's typically handed off to a package distribution, and you can also attack the package distribution point. Finally, you could get the user to use a bad package. And as I mentioned in the article before with the reflections on trusting trust, attacking the tooling of developers is becoming more and more frequent to inject malicious code or malicious functionality within the software supply chain. Here's an example attack from Codecov. Codecov is within the software supply chain. It's a developer tool. And what it does is it tests your application, and it checks how much your application is tested as part of that CI pipeline. What an attacker did using some stolen credentials from, I think, a mistake from a container, the attacker was able to modify a bash uploader script within the Codecov solution. Then the solution was distributed to a lot of developers, large organizations, as it's referenced there, earlier this year. And so there was roughly around, Codecov had roughly around 23,000 customers and users. And anybody using this compromised version of Codecov would have been compromised. What happened was the attacker, the impact of the attack was secrets are uploaded to the attacker's remote server. One of the things that was interesting with this attack and could have helped was a concept here. Actually, no, a key concept here that did help in this attack was a code signature was identified to identify a hash mismatch. This is how the malicious code was identified. So signing your artifacts throughout the process is a very, very good thing to do to help identify malicious intention within the supply chain. Okay, more problems. All right, I want to talk about a tool called Salsa, talk about some repository controls, and another tool called SourceRank. So Salsa, supply chain levels for software artifacts. What this is, it's an end-to-end framework to ensure the integrity of the software you are using or including is secure. It primarily focuses on the attacks between B through G and making sure that that process is very mature and solid. It's got 4 assurance levels, 4 being the most assured, the most controls. It is a compliance framework, and another way to put it, it's a compliance framework, and there's a bunch of controls. There's roughly around 30 controls, checks to make sure that will get you these 4 different levels. 1, I think, is you just have a few different controls, and 4, you have all like 30 controls. And there's levels in between. This really helps empower our software development teams to automatically check the integrity of software artifacts when they choose to include into their projects. This is developed in direct response to these known supply chain attacks. It also includes SBOM validation, code sign scoring controls. Another thing to note, that effective use of SALSA could have prevented the Codecov and the SolarWinds attacks, or at least could have detected it. Another interesting fact is Google has been using SALSA since 2013, well, their internal version of SALSA since 2013, and they require it for all their production workloads. There are some similar alternative models out there. There's the OWASP Software Component Verification Standard, SCVS. It also has very similar assurance levels 1, 2, and 3. There's Microsoft Supply Chain Integrity Model, or SCIM for short. And there's also Cloud Native Computing Foundation, CNCF's Software Supply Chain Best Practices, all very similar models. So let's see how SALSA can be applied, or a solution like SALSA can be applied. If we have a compromised open source project that's SALSA assured at SALSA level 1, and by the way, SALSA, each open source project will be scored, provided an assurance level, so individually. So SALSA level 1, if there's the two middle open source software projects there, their higher level software assurance levels, they may not want to accept SALSA level 1 inclusions into their project. So it's going to be stopped right there. So one of the things that the SALSA team wants to see and wants to do is help other projects to all get SALSA assured. And so that's going to be very difficult to gain adoption. I don't know necessarily sure how they're going to go about doing it, but they do say that they are suggesting third-party assessors to assess your project and then give you your assurance level. Okay, I want to focus more onto the developers and submitting bad code. This is more along the lines of malicious code injection. People actually inserting malicious code. There are some tools like package analysis that help detect behavior-based maliciousness, using behaviors, heuristics, to help identify malicious code in their software. There are some tools for the software composition analysis tools which can help detect malicious code detection. However, in my opinion, with the research that I did and the attacks that I've reviewed, tooling cannot effectively detect malicious function injection. Yes, security industry is very good at detecting things like remote access tools, viruses, and those types of things that are known. But we're talking about developing, code. So that is very, very difficult to do. So what are the code repositories doing to help with this problem? Well, obviously, there's Linus's law on code reviews. Have multiple eyes looking at code, looking for malicious functions, malicious testing. That's kind of very obvious. Malware scanning, it works. I mean, it's got a purpose, and it's not the best. But what I was really, in my research, I was really proud to see and excited to see that most repositories have really good IR teams. GitHub's instant response team, PyPy's Python instant response team, they all have processes to quickly respond to, once identified and notified, to malicious code. So they have quick takedown processes and quick advisory processes and alerting processes to let downstream projects know of the malicious code. GitHub, for example, they list their malicious code notifications as vulnerabilities. So you can actually search them as yourself by looking at the advisory database and searching for the terms malicious package, and you'll see a lot of different interesting malicious code injections. Okay, on the other end of the software supply chain, I want to talk about packages and repositories and attacks on them. Again, these are the YUMs, the APTs, and the solutions that distribute your software. An attack that's becoming popular is called typo squatting. You all have gone to a website and typed the wrong website and saw a page you wish you never saw. It's like that, but with dependencies. You type the wrong dependency or package or project, and you got maybe code that actually works, but it actually has laced with malicious code or malicious functionality. It's a bigger problem that's happening lately. A lot of code repository tools are looking and watching for these types of things, but it's still possible and very possible to happen. So package scoring. When you want to use a package, there's a solution called libraries.io, SourceRank. And what it does is it helps collect, it's another scoring framework that looks at scoring metrics for quality. And the input for this tool are package managers, or packages from package managers. It looks at things like the project, the version, and its dependencies. Your input there is your package, and output is, like I mentioned, scoring metrics that could be very useful for automation and risk-based decision making. So stepping back at a higher level, this is for you managers and risk quantifiers out there. To wrap up the presentation, quantifying probability is going to be different for each organization and project. It really depends on what your organization does to really understand the probability for attacks to your application, your project, or your organization. If you're in government, critical infrastructure, financial, crypto, they seem to be very high targets. If your organization or project serves code that references a nation state, critical infrastructure, industrial control systems, high value asset, then your probability is increased, I would suggest. The good news is, I guess the good news is, it does take a high amount of expertise and sophistication to pull off a really a good attack. I feel like there's a lot of, while there are a lot of publicly recorded software supply chains attacks out there, there's probably a lot more that happen that's not publicly posted. And again, it's just more of the nation state actors doing their things. So the impact obviously can be very high. Cyber warfare, espionage, disruption, distraction within is also very possible. So the amount of attacks, there's about 900 a year roughly, and it is increasing as referenced from the Sonatype report. This is a reference. It's a good reference to look at. It gives you some more numbers. It actually talks through this whole project, the whole problem of open source software supply chains and attacking them. It's a year or two old, but it's a very good report. Again, it has a lot of different statistics and numbers and presented in a really good way. I just wanted to reference. I thought was very helpful. All right, so what can we do? Well, we continue to analyze our applications and our organizations for their risk and identifying controls where they might be most important. I would also consider, within your supply chains and your CI/CDs is to utilize SBOM and sign everything. Those two things are just very quick, easy and quick wins for your supply chain. CSPs have a lot of tooling and processes, obviously, to make DevSecOps easier. Continue maturing your software inventories. CIS top 20, or number 2 is your software asset management, top control, number 2. So that is really very important. Consider the dependency and package management scoring utilities and develop minimum acceptable scoring criteria based on organization risk tolerance. Okay, so I mentioned that I went through a learning journey, and I learned a lot. Did I get the answer to my initial question? Yeah, kind of. Can we trust open source code and binaries not to include malicious functions? My answer is, well, kinda. It really depends on what you do. As I mentioned in the previous slide, You can be a target. Certainly financial is going to be a continued theme within the motives of cyber attackers. I did learn also that open source, it's just huge and it's getting older. I learned that there's a lot of challenges with the open source community. And with getting older comes potential security issues. The need for visibility scoring to support automated dependency management decisions is getting better. It's increasing. But our tooling is getting better. But I encourage you to contribute to these tools because it's really going to help us to continue to, as an industry, can develop really good, secure code. I've learned about SBOM and how easy and important that is, I mentioned earlier. And projects that are included in many other downstream projects are very, very important. And the ones that aren't being maintained or ones that are expired are really, really concerning. And I know there's a lot of work happening with several different groups to help address that problem within the open source community, including government assistance. Financial gain, as I mentioned, is a primary motive and seem to be the top software supply chain attack motive. Vulnerabilities, as Sid mentioned, I didn't want to talk about vulnerabilities because there's a lot of different talks about vulnerabilities within the open source supply chain, but they're still very important because they can be maliciously injected. But they're still also, and it can be purposely not corrected as well. The integrity of coding, the development tooling itself is very, very important. Those supply chains, those tools, the developer tools are being attacked and then exploited within our software processes, our development processes. I was very, like I mentioned, I was very happy to see that open source code repositories have really good controls to identify malicious intent and respond to malicious intent and malicious injections. I also learned that developing a presentation is a great way to learn and help the community at the same time. All right, so thank you. That is my talk. I have a lot of resources here that you can download. If you want to take a picture, go ahead, take a picture now of the URL. And but I do have a special, I do want to say thank you to a few that listed at the bottom there: Rick Yoakum, James Stingler, Mike Prinke, Peter Genesis, and Matt Kerr for helping with the presentation. Thank you guys, much appreciate it. You guys are awesome. Questions? Thank you. Questions, comments, thoughts? Sivram, love you too. Software control management solution. Yeah. So the question, Sivram, let's make sure I get that right. Where is a challenge within the software development lifecycle? Is it more on like the GitHub in the software control management solutions? Is it in our CI/CD? Or is it in the package distributions? Well, I can tell you that the package distributions are, there's attacks that come and go. Typo squatting, namespace confusion, those are attacks that they're the rise, and I think us as an industry will correct them. As long as with the software control management solutions, like GitHub, the attacks that I've seen, at least with my research, fairly even throughout the attack cycle. They're attacking all different points. What I've provided is just like a high-level architecture view of the attack threat, the attack types. But I can't say that one specific part of the cycle is being attacked more than the others, because a lot of the data and the research that I've read is kind of across the board. Good question. Does that answer your question? Okay. All right, everybody. Thank you very much.
Thank you again, Ryan. Great job.